Hello everyone, dear tool grinders and friends of NUMROTO. Here we go again with the fourth episode of our Sunday Tool Talk series. Today we have a special edition, Automation with NUMROTO. As you know, times are not getting any easier and we must adapt, for better or worse, true to the motto, change or get changed. Today, I would like to discuss the many wonderful possibilities that NUMROTO has offered you for years, plus a few current innovations that drastically improve flute grinding in production. Today, we will discuss the following areas of automation: considerations and techniques for automation and the new dressing or sticking on demand function. But before we begin, thank you again for viewing my content. It's amazing how many people you can reach here. It's impressive that you can reach several thousand people interested in tool grinding. That's why I'm always pleased when I look at the LinkedIn ratings. Right on. So today we have a special edition of Automation with NUMROTO. It sounds good, doesn't it? And why is that? Because you can increase your real productivity. In other words, you'll have more profit, success, planning security, and a better future. That's why I would like to encourage all of you to take advantage of what NUMROTO has to offer. Don't be afraid of new technologies or grinding processes. The sole purpose of a machine is to run. Machine downtime means losing money. And I often see that many companies simply switch off their machines at the evening. Perhaps the last tools are still running with the loader, but unmanned production is usually only done by those who produce high quantities or standard tools. So the question is, why can't you? Everyone can concentrate relatively easily on a handful of tools that sell well, which can then be produced specifically in the hours when nobody is around. And that's exactly where we can help you. We can help you with the automation and its functions, or with optimizing your tools for it. And for those of you who already produce tools automatically, we have important tips and tricks ready to help you reduce cycle times, improve quality, and maximize the number of tools you can grind. If you're interested in learning more, please contact me directly. Okay, Sunday Tool Talk special, Automation with NUMROTO. Topic: manufacturing know-how, considerations and techniques for automation. So, what does automation mean in everyday life? So, automation can mean quite a lot of things. So, basically, we have to separate highly automatic standard tooling, like lights out production and such things, or even daily operations, special tools and small series. And that's the good thing. NUMROTO has it all. You just have to know how to use it right. And we have implemented quite a few nice techniques that cover everything. So for example, drill production, subland, so we grind the diameter, right? And that is especially here, if we're talking about like daily operation or special tools, small series. And then even if I have 5 or 10 tools, if you have a small tolerance, and I probably need to check every tool, right? Measure it and make my adjustments in my program. So here I can just use an automated process that sends the machine to the surface, to the diameter, probes it, and it will adjust the diameter automatically. So that would be small series automation, right? And on the other hand, I can automate the process, if you have a good written program, so that it basically runs light out production 24/7 for several days, that works. And so this is really automation in everyday life, But important is, and I have written down quite a few things here. So what are the essential considerations? What needs to be taken into account and which techniques need to be known? So what I mean with techniques, it's the features NUMROTO offers you, you know. And so basically, I want to briefly talk about 5 things. And those are the 5 most important things, I think, and that is probing and measuring in process heat compensation, wheel dressing, and wheel sticking. And of course, our popular inner control. So we start with the first one, probe and measuring a process. You know, I already talked about like the subland drill, and that will be like the perfect example of probing and measuring in process. So basically what you do is you just set up your process, you send the machine to probe, you know, like a diameter and adjust for it. So then the wheel gets a specially assigned parameter that can change, and based on the probe values, the wheel will automatically adjust. You know, that is awesome. And I strongly encourage you, you know, take your time, play around with this. And if you are a boss, a owner, you know, give your employees the time, you know, and you will get rewarded by it. And that will be the probing and measuring in process. You know, I love it. It's fantastic. And that is just one thing. You know, you can do, I mean, I don't have enough time to talk about this, but this is just the most common example is probing a diameter, adjust the wheel, you know. So the second one is in-process heat compensation. Because, and coming back to the first one, and then you have some people say, yeah, well, we already tried this, you know, probing, measuring, and process is all garbage, it's not working, and blah, blah, blah. It is working. You just have to properly set it up, and you have to know what you do. So there are many different aspects to it. So even if I probe and measure in process, but your program is completely twisted, and you don't use, for example, the right compensation techniques. You know, there are different ways you can compensate. For example, you can only compensate 80% of the measured result. You know, and such things you just have to notice. But a common thing, what I always get is, yeah, we tried this, and then we have problems with heat expansion. And other things, or the oil is changing. And yes, this you are right. But that's why we have that second point, and that is the in-process heat compensation. You know, this is a really wonderful feature. So basically what it does is you have like a calibration block in the machine. And before you start, you know, you send the machine to that block and say, okay, probe, probe, probe. And those values get saved. And then over time, like for example, if you load 50 or 100 tools in your loader, you know, with inner control, which we come later to, and then you can just say, okay, after a certain number of tools, for example, you know, go back to that calibration block and measure again. So now the machine will go to that block, pop, 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 and it says, oh, y-axis expanded by 15 microns. And the x-axis maybe just got a little smaller. And then it will compensate. It will automatically compensate the heat expansion or shrinking. And you know, this is great. It's a great feature. Especially if you want to do, if you work accurate. And I mean, you know, not, you know, you can do this up to a few microns. And I mean, not a lot of people even know what a micron really is. So I'm still amazed by how accurate those machines really are. You know, a micron is really, it's nothing. So, and those things can drastically improve your automation process. So the probing and measuring process and in-process heat compensation, great features. And then the third thing, what I have here is the wheel dressing. So you can dress your wheels directly in the machine. So you can just do a simple wheel dress like a 1A1 wheel or cup wheel, or even, there is the new, it calls X dressing. It's also a feature. You can do even form wheels. So, and also the wheel dressing can be done fully automated. So you can say, for example, after 5 tools, or that's the new thing, you can do it after you reach a certain spindle limit, but we come later to it. And I know it's overwhelming at first, because if you open that box and you have that function, then you have 10 different dressing units and ways, and how do you want to compensate, what is with the parameter in the wheel and so on. But take your time, and also invest that time. If you have the tools and the right orders for it, that is just the way to go. This is just wheel dressing is it's great. You don't have to do it outside. So basically, you can start with a freshly dressed wheel in the machine. You can use it for many different things. Then also you can stick the wheel. Wheels get, the diamond, it wears off. And especially if you have a fluting process which is not optimal, let's say optimal, because an optimal setup fluting process, the diamond wheel will resharpen itself automatically. That is the perfect process. But for this, the wheel needs pressure. So if the diamond corn, it gets slowly round, and if you have enough pressure, and the corn will be released automatically, and a new corn will be exposed to the carbide, right? So, but sometimes, it's not possible, or you just can't, and then you have to stick the wheel. And now we're talking about automation. So automation means you can automate it by just, use your employee to open the door and white stick the wheel. He opens the wheel, like the bond, the diamond opening. And then he adjusts the wheel, and he's good to go. But I can also do that in a fully automated process. You can just put that white stick stone into the machine. And then also here you can say after 5 tools, 10 tools, or, with that new function, which we come later to. And so you can automate that process. And especially the wheel sticking, if you want to do a lot of tools, big tools, like a 50 or 100, then you need to be able to stick the wheel in process, fully automated in the loader. And we can do that. So NUMROTO has the capabilities, and this is old stuff. This is implemented, I don't know, like how many years. And I'm always wondering why so less people using it. It's just, I almost feel like people are afraid about new functions, and I get it. It's new, you don't know it. But also here, you can just call your machine manufacturer and ask for a test license. Ask them, get a test license, and then, get your own experience. And also we are here as well. So if you don't like us, go to the machine manufacturer, or, try us. Doesn't matter. Okay. Last thing is, of course, our popular NR control. So that is the loader software, and everything we just talked about can be done automated in NR control. So, and also in NR control, you can do, for example, 50 drills, and after the 50 drills, you can do end mills. You can do regrind. You can do everything. You can probe and process, measure and process, heat compensation, wheel sticking, wheel dressing. It's all possible. and that is the NR control. I mean, regrind with, with the law. I'm not a big fan of that. I'm just too lazy, to just measure every tool and put it in. This is just a pain in the butt, but this is just my opinion. So I think the loader should be used for, production. But yes, so NR control is a great tool. And the recent updates, it got improved with the cycle time, so everything gets calculated. And also, if you just turn down, your feed rate, your body, it will automatically calculate the end time, and it's just great. So let's put it that way. Yeah, and those are indeed the 5 features you need to work on. Get you know-how, get you examples or whatever, and use it. Yeah. So there is indeed everything you need to run the machine even for several days at a time without anyone having to touch it. And you can believe me, that really works. But, and now we come to an important point. And those are the further considerations. What requirements must be met for all of this to work? Because on paper, everything is fine. It's on paper, everything is easy. So if you want a highly automated process, then your program needs to be optimized. That is extremely important. If your program is not good and not optimized, all those features are worthless. Like if, it's just a waste of time. So you cannot start with automating processes and measuring a process, probing and whatever, and measuring rake angles and whatsoever. This is all useless if your program is not written properly. And here the most important things in my mind is the optimum feed and the cycles. So that is just super important, because I often had those discussions earlier in my life, let's put it that way, when the boss came up to me and said, yeah, we have to make it faster. And I said, no, I just don't. Like this is my field. I'm in production, and if I make it faster, the process is not bulletproof anymore. We should always go by a bulletproof process. You can make it a little faster, but you just lose at the end, because then your wheels get overloaded and everything has a limit. So you can make it a little faster, but then I go from 50 tools without touching the machines just down to 5. And in the worst case, then you can take the wheel out, give it to the wheel dresser. He needs to dress the wheel. I have to dial it in again. This is just not, you don't do this. And this is mostly the problem if somebody from the office comes out to the shop and he wants to explain you how to work. Let them do their stuff and I do mine. So, but of course, you can only talk to your boss like this if you are experienced, It's never good to argue if you don't know what you're talking about. So, but it's just important, to have like your program optimized, and especially the feeds and the cycles are important. And here it's QW, removal rate, aggressiveness. There's the feed rate per diamond corn. This is, you might do a Sunday ToolTalk special just on that, because this is just so important. Also important for the program is definitely the roughing where necessary, especially DXF steps, or example fluting, for the fluting. If you want to automate a process and I'm talking about high quality tools, not some garbage. So if I want to produce high quality tools, I can't do it with one fluting wheel. This is just, it's just reality. So If you just put one wheel in and then in your mind you just probe it in process and everything will be fine, you're lost. This is just, it's not gonna happen. Because your radius on the wheel will change, but the radius in the program will stay. And then you have a mismatch. And that's especially important if you wanna, for example, high gloss flute polishing. Then it's even more important to have like that bulletproof program ready, because then you just live by the stock for the polishing wheel, right? So you might maybe have like 50 microns you want to remove, and then the steady stuck, that's the key to success. And you can't do that with one wheel, because that one wheel, the radius will change, maybe some angles, and the wheel will just lose its shape, its geometry. And because of this, you can't secure like a steady amount of material to remove by the polishing wheel. So much about high gloss flute polishing. And the same applies if you want a nice geometry for even like a standard drill. It makes a lot more sense to have like a roughing wheel and remove like 80 or even 90% of the material, and you don't have to be worried about my end geometry and the wheel geometry, and because you can just basically just probe the wheel from time to time in process, and then you have your second wheel which comes in and only just skims slightly material off, and then I can run like 100 or 200 tools without worrying. And that is automation, Everything else is just playing or producing garbage. So that's the reality. So, and that's why I'm talking about program, wheels, wheels, wheels. That is the most important thing about automation. And the same thing applies if we talk about roughing for DXF steps. If you have a DXF step which is not pre-ground, which is basically just OD ground somehow, and then you go in with your cup wheel or with your form wheel, that wheel will just not hold up long. So it's much better just to take an old wheel, like an 1v1 wheel, 30 degrees, flip it, and copy the operation, set it off like 0.2 up, 0.2 out, rough it, and then just come in with your finishing wheel, and that's a process, and then I can do 50, 100 or 150 tools. Don't need to worry, right? So program is key for automation. Very, very important. Conclusion: decide what you want. If you want to run just a few tools in the evening or over the weekend, or do you look for highly automated processes, for standard tooling? This is just important to make the difference here. Also, you should note that automation is possible with almost all tools, small tools, big tools, special tools, long tools, short tools, steady rest. It's all possible. It should of course be a reasonable number of pieces so that it is cost efficient, because the setup process takes time. Yeah. And just like I said at the beginning, it doesn't make sense to set up like, 2 or 3 hours and then you just make 15 tools. You can just do that over the day. Yeah, and also, of course, very important is, if you want to automate something, you have to know what you do. Like if I come in at the morning and I open the door to my chain loader and I pick up 150 scrap tools, that is not good. So, and if you want to avoid this, you need a proper training. But that's the good thing, we can give you this. So, and that's why I can only encourage everyone, take a look at this, use the capabilities of NUMROTO. And believe me, what's hard at first becomes easy with practice. Okay, good stuff. Next topic, NUMROTO know-how, dressing or sticking on demand. So why use on-demand dressing or sticking? And today is Sunday ToolTalk special automation, right? And that's why I want to talk about that new feature, and that's called basically dressing or sticking on demand. So as we talked about, large orders with high quantities require a stable process. And here even, one example, especially important, the fluting. Your fluting wheel needs to be sticked from time to time. And but if you have nobody standing in front of the machine, so who's going to do it, right? And so with that new function, dressing or sticking on demand, it is possible to create like a system where you set a spindle limit, like, I don't know, like, let's say I set up my fluting with 60% spindle limit. And then I know at 80% it gets critical and it needs to be white sticked. Then now it's possible to set an E parameter. So the E parameter is normally like say it's at 0. And now with my value, I set it at 80. And then if it reaches 80% spindle load, and the E parameter will switch from 0 to 1. And then it will noticed by the software, and it will say, oh, that parameter changed, and now that is my trigger point to stick the wheel. And that is new. And that is great, because lights out production, and basically you can optimize that now. So you don't need to stick like randomly, or like we already had the option to stick after 5 tools or whatsoever. But if that number is not set right, you either lose time, you lose, you stick too often, or you stick not enough. So now that is really cool. So what does it mean is really, I don't have to worry at all about that problem anymore. This is a great new feature. And also I can use that, and that is also a feature I can use in daily production. Sometimes also people stick the wheel differently. Usually back in the days, we always had like a little sticky note on the machine, and it says stick wheel every 5 tools. So then you have the new guy, and he just came in and he took that stone and just, like a little bit on the wheel. Like, that is not enough. That is not wheel sticking. That wheel needs, like, that you need pressure. Like, you want to remove the bond with the old dull diamond corns, and you want to release new ones. You won't do this if you just take the stone, and just, tickle it a little bit. This is just, you need pressure. So, and what happens if the one guy is like doing it properly and the other is like just not doing it basically at all, and then your spindle load will just increase, and you may smoke up your wheel, and you don't want to have this. So now that means you can do that also in everyday production. You set up the process, you just type in your values and say, okay, spindle load reaches 80%, stick it. Great. I really love it. Yeah. And so that much about sticking on demand. So we also, I introduced dressing on demand. That's basically the same. Yeah. So you can say dressing on demand, dress the wheel if you reach like a certain spindle limit. So for example, if you have like, like CBN tools, and the thing about those CBN tools, if you just oscillate like a how are they called in English? you know, those ball type CBN tools, yeah, doesn't matter. But here is important if you have like a flat wheel oscillating, you know, and then you could say, okay, you reach a limit, and then I don't want to stick, then I want to dress, because those CBN tools, they wear out your wheel. And if your surface isn't flat anymore, you know, and then you get like a radius, and then you can't create geometry anymore. So, and now you can say, okay, if you reach a certain limit, probably not like a high, it's not a high spindle load, maybe let's say 15 or 20. And then you say, okay, now execute wheel dressing. So that will be wheel dressing and wheel sticking on demand. And that is done with an E parameter and with a certain setup in NUMROTO. Yes. And I want to show this to you quick on my computer, you know. There's basically not a lot to show, but I just want to make sure that you know where it is and how to use it. Okay, and I think that should be it here. Or do I have anything left? No. I think I'm gonna see you at my computer. Thank you. Okay, we are back here on my computer. And I wanted to show you very quick how the dressing or sticking on demand works. So first of all, of course, we need to choose the operation. We want to you know, set up that whole procedure. And here in my example, I choose that flute. Okay. So what I'm going to do is, you know, here AC, adaptive control system. I activate that. Let's say I want to have 30 amps as my max allowed spindle power. So I'm going to set this. So what that means is, so if let's say you set up your flute and everything grinds perfect with around 20 or 25. And then over time, like tool by tool, it will go a little higher, and then the wheel is basically loaded up with carbide. You know, let's say that is 30. So, and then on 30, I want to set the order, okay, machine, please stick the wheel. So that's why 30. And now, of course, we have to set up that whole mechanism, you know, that feature. And you find that under machine, edit machine data, AC. So basically everything is done here. So that should be automatically set. So don't worry about this, and this explains itself. So the max spindle power, of course, that is your maximum spindle power of your spindle. And now you find a different wording here. So what does it mean? Minimum feed rate. You know, we just talked about like exceeding certain values and then send the wheel to sticking. But now here I'm, you know, what's minimal feed rate? And, you know, this is just a thing. So that feature was implemented, you know, in a different way. So I think not in the best way, but it is what it is. And so basically the feature will work now if the machine already reduces your feed rate, you know, which doesn't make sense at all. And so basically now the machine will only stick the wheel if your feed rate is already reduced by 20%. But what, you know, it means basically if you have like a series of tools, you know, maybe from tool 10, you go over that limit, then the machine will reduce your feed rate. Then tool 2 and so on until you are at 20% reduced feed rate. And then the machine will stick the wheel. You know, this is not very practical. And also you can't go over 80%, right? So that's why, you know, I ask about to change this to 99. And then we can use the feature like it's supposed to be used, you know? Because with 99%, basically your wheel will load up over your cutoff value. The wheel is dull, the wheel is worn out, and then the machine will try to reduce the feed rate, but even, it reduces just 1% and then it's going directly to stick to wheel. So I asked for this to be changed, and just have a little patience. So it will be rolled out in the next big version. And then you can use this in a more efficient way. So then just forget about the minimal feed rate. But of course now it's just 80, but it will change. So let's assume we have the 99 programmed, we have our cutoff value set at 30, our flute is set up with 20 or 25, and then it will reach 30. And then we need to go into our wheel, dressing units, that is German, but it means sticking. Then you go into your operation, process, and then here, that is important. Conditions that must be met for dressing to be performed. It says dressing, but it is sticking. Just notice. Okay, so execute dressing if E parameter greater than 0. So this E parameter is it's different from machine to machine. So if you have a Saki or a Star Cutter or a Vollmer, that can be different. This is just an example here. So don't type that number in, okay? You have to ask your machine builder directly. But here basically, this is the E parameter number. And as I explained already, previously, if my cutoff value 30, if that gets higher, and with the 99, then the E parameter, it will be written, it will flip from 0 to 1 or whatever, and then that gets noticed and the machine will move and stick to wheel. Okay, so for all the experts, I'm sure you have one important question, and I said, that's all nice, but what like we talking about automation. So if I stick a wheel, I'm probably use like quite a lot of my diameter, so I need to probe it, but I don't have that option here. So that was another thing I asked, and that will also soon be implemented. So then you have the function of the 99% minimal feed rate, and you can send the wheel after sticking directly to be probed. And then everything is perfect. Then you can work with it like it's supposed to be. And of course, here dressing units, this would also be the place, dressing, truing, and there is many different things here you can choose from. But just wanted to talk with you about the on-demand sticking. So remember, set your spindle power when you want to stick. Then of course here you set your value here. Then the rest is done directly in the dressing, and then you should be good to go. And that is also what I think it's the great thing about NUMROTO in general, also because of the many different machine manufacturers they have. So every customer has different needs. You have some only do specials, they other do insert big tools, small tools, and long tools, and special tools, all kind of special tools. And at the end, everything at one point gets directly to NUM. And that's why this system is so round. There are still many things I like to be improved, but at the end, I think it's quite good. And especially if you look at the features that we have for automation, it's great. So yeah, and that's about it. So very quick, no nonsense. And yeah, I hope you use it in the future. Thank you. Okay, that's about it. Sunday Tool Talk special automation with NUMROTO is over. I hope you enjoyed it, and I think we did a pretty good job. Of course, this format, it's not about getting into every little detail. It's just an overview, and I'm just giving you the concept of things, and I want to encourage you, to work more with NUMROTO, get your know-how, get your knowledge, and because you will be much more successful at the end. But again, thanks for watching, and if you have any questions, comments, or whatsoever, reach out to me directly if you want. You can write me an email or go to my website, get your infos over there. And also, like the video, share the video if you want, comment, or write me a private message over LinkedIn. It's all possible. Just you can only change if you do something. So, and we are here for you. Thank you.